Welcome to this introduction to blockchain. But before we start, let me briefly introduce myself and our company. My name is Arno Laven and I am co-founder and CEO of Warren Brandeis, trusted advisors for the trustless era. We are a strategy consulting firm and we help our clients understand, explore and use decentralized technologies like blockchain to solve some of their most complex challenges. We create solutions for verifiable ESG claims, decentralized data spaces, digital product passports, decentralized identity, and much more. Do reach out to us if you would like to find out more or go to our website warrenbrandeis.io. We are going to talk about what blockchain is, and I will explain how blockchain works to hopefully increase the understanding of blockchain and decentralized technologies. But talking about the inner workings of a blockchain makes as little sense when trying to understand what its meaning is as explaining the internal combustion engine when you want to understand how mobility changed society in the 20th century. And therefore, if you allow me, I would like to start with a glimpse into what we think is a not so distant future. And in that not so distant future, imagine that a Tesla drives up to an electric charging station. And a person gets out and plugs the car into the station, and she walks to the Polestar that is parked next to the car that she arrived in. She unplugs the Polestar from the charging station, gets in and drives away. Now while doing so, she never swiped the card, she didn't actively check in, she didn't even take her phone out of her pocket. All transactions were done machine to machine. She doesn't own the Polestar, she doesn't own the Tesla. The Polestar is owned by 10 investors who make an annual 12% return on their investment, and the Tesla is owned by Tesla, who do not disclose the return on their vehicle. Welcome to the decentralized society. And this society is a society in which people, things, and organizations seamlessly interact peer-to-peer with each other in both the physical as well as the digital world in a distributed network that stores state and runs code. It's also an economy in which individual assets, in whole or in parts, can be tracked, traced, controlled, and traded. And that opens up opportunities. For instance, for fractionalized ownership, tracking carbon, micromobility, provenance of food, transparent supply chains, to name a few. And in that society, organizations and institutions still exist. So not all is decentralized, but what can be decentralized will be decentralized, for the simple reason that it leads to better outcomes in the highly complex world which not only spans the globe, but also that which we call cyberspace. And with that introduction, let us turn to the inner workings of blockchain. And let's have a look under the hood of blockchains. And I want to start with a definition. And if you ask 10 experts, to give you a definition of blockchain, you will get 11 definitions. This is ours. A blockchain is a transparent, tamper-proof, immutable, and distributed registry of data and logic. And to understand what that means, let's relate it to something we know, databases. So databases as we know them today are centralized registries, maintained by one specific or several specific parties. Interaction with such a database goes through that third party, who also validates the identity of the person, organization, or machine that is interacting with the database. And that creates a heavy dependence on the central party maintaining that database. Moreover, it creates a honeypot for hackers who, once they have access, can see and use all of the data that is stored there. But also these centralized databases could be inaccessible through malfunction, for example, or because of censorship. Just think of deplatforming or shadow banning, something which is very relevant these days. And that's why in 2008, a pseudonymous inventor called Satoshi Nakamoto published about Bitcoin, which is the original blockchain. And this blockchain is none other than a network of nodes running a registry which can hold data and logic, and with logic we mean computations, in an immutable and tamper-proof way. So a blockchain, by contrast, is distributed, which means that there is not one database or registry, but there are many. And they are all copies holding exactly the same information, and they are distributed over hundreds, thousands, or even hundreds of thousands of computers around the globe. And that makes the registry highly resilient. As long as one copy still exists, the blockchain still exists. Now, if you have thousands of copies of the same information stored globally, there needs to be a mechanism to update the registry with each new entry into it. And that is done through a consensus mechanism, which is a set of strict rules with predefined incentives and a cost structure. And that makes it costly and difficult for one party to unilaterally remove or modify data stored on a blockchain. A consensus mechanism consists of two parts. One part is that the nodes agree on a new set of transactions, and that is actually the last part of the mechanism. But the first part is maybe the most discussed, at least, and it's certainly also interesting part to understand. Because first, all the transactions that have been broadcasted to the network have to be proposed by one of the nodes. And which node proposes the transaction for validation needs to be randomized, as we otherwise would still have a quasi-centralized solution in which one node has all the power. That randomness can be achieved in several ways, of which the three most important ones are mentioned here: proof of work, proof of stake, and proof of authority. In all three cases, there is something at stake for the participating nodes. In the first, it's money spent on energy to solve a difficult mathematical puzzle. This so-called proof of work protocol is used by Bitcoin and several other mainly cryptocurrencies. It is highly wasteful, but it's wasteful on purpose. And because it's wasteful, it is being scrutinized by the public and by politicians alike for wasting a lot of energy. By contrast, proof of stake is a protocol which does not consume that amount of energy, because it's a protocol by which there is a random selection of a node that can propose a new transaction, but the probability of being chosen as a node is higher if you stake, that means lock up, a certain amount of the underlying cryptocurrency. And this protocol is used by Ethereum 2.0 and consumes only a fraction of the energy of proof of work protocol. So that whole energy discussion that is going on around Bitcoin and other cryptocurrencies using the proof of work protocol is no longer applicable when it comes to Ethereum and others using proof of stake. And the same is true for the third method of consensus mechanism. And the third method is called proof of authority, in which what participating nodes put at stake is their reputation. Therefore, this protocol is mostly used by networks in which all participants and / nodes are known entities. So these are mainly industry or consortia blockchains. Now, how do we interact with a blockchain? Well, public-private key pairs are crucial to blockchains, and that's how we interact with them. So instead of having a username and password that is held by a third-party service provider, you actually hold a key pair, of which the public part is like your username, or maybe better, like a web address, and there's a private part which is your password. The two are cryptographically linked. The public key is derived from the private key, but you cannot reverse engineer that to the private key. And that means that in order to have control over a public key, you need to have the private key. So anyone using a public key to sign a transaction can only do that if they also hold the private key. They can, in other words, never deny that they signed the transaction, and in legal terms we call that non-repudiation. But it also works the other way around. If someone makes a claim about a data point or about a transaction that originates from their key pair, they can simply prove that. And there is a very interesting case. As you know, or as I explained earlier, Bitcoin was brought to life by Satoshi Nakamoto. No one knows who that is. But there was a person who claimed to be Satoshi. There would be a very simple way of proving that, and that would be by signing a transaction with the same public key that everyone knows that belongs to Satoshi. But, of course, he never came up with that transaction. Instead, he came up with all kinds of reasons why he could not do that. Clearly, the man is a fraudster. Now, there are several types of blockchains, although not everyone would agree that they all deserve to be called a blockchain, but that aside. The main distinction is who has access rights and who has the right to validate transactions. Read-write access can either be public or private, and the name already reveals that in a public blockchain, anyone with a computing device and an internet connection can access the blockchain and read or write transactions. Validating transactions, which is on the other axis, and which is part of the consensus mechanism which we talked about earlier, can either be permissioned or permissionless. And also here the name already reveals which is which. Permissionless blockchains allow anyone to become a validator. Take the Ethereum blockchain. If I have the right equipment and if I stake Ether, the underlying cryptocurrency of Ethereum, I can be a validator or miner in the network. I don't need to ask anyone permission for doing that. By contrast, to become a validator on, for instance, the energy web chain, I need permission from the other validators on the chain, which in this case are all large energy and telecom companies like Engie of France or Vodafone UK. Then we also have completely closed systems in private permission chains, which are mainly used within specific industries. At Warren Brandeis, we believe that blockchains should be definitely public and preferably permissionless. Technically and architecturally, there are really no reasons to have a private permissioned blockchain. If participants are worried about confidentiality of their data or of their transactions, there are other technical solutions, or it concerns data or transactions that anyhow do not belong on a blockchain. As part of our work, we help clients to understand these kinds of intricacies and co-design proper solutions. Now with that, let's turn to why this actually all matters. So when we think about what it really means, this strange technology of blockchain, we really should look at what it does. And by getting independent of an intermediary who says something about the validity of data, logic, and a transaction, we have, if you will, a shared truth about a transaction, about data, about the state of anything. For instance, about a transaction. And that means that we are no longer dependent on a third party when it comes to the integrity, both of data, but also of logic. And that has many benefits. Lower costs, for instance, but also the ability to share data and logic among a very large group of participants that do not need to know or trust each other, and where there is no third party available, or in any case where the cost for having a third party would be too high. Just think of long and complicated supply chains, or think of sustainability claims which are global by nature. Let's have a look at these separate elements and give some examples. To illustrate why integrity of data is important, let me give an example that most of us can relate to. Let's say you are buying a second-hand car. The information about the state of the car that you're buying is given to you by the seller. It is in the seller's interest to make the car as attractive as possible, of course. At the same time, you will not trust them fully on the information that they provide. Now, what if we could collect all data related to a vehicle all through its life cycle? And that is exactly the question we asked while working with a client. We came up with what we call a vehicle passport. All relevant data and or the proofs related to the vehicle are accessible through a digital passport. So when you want to buy that car, you can see all the data points. But still, the question is whether this data is truthfully represented there. And that's where a blockchain comes in. First, by making the data provider accountable, as they need to digitally sign the data they provide at any given time in the life of the car. And secondly, by hashing that data and storing that hash on a blockchain. Which means that if you change even one bit in the original data, the hash will be broken and you know that the data has been tampered with. Now, such a solution is not blockchain only, obviously. As a matter of fact, no solution that interacts with the real world is blockchain only. So we also need IoT devices, AI, or cloud storage. But the blockchain part is important as it allows the solution to exist without the need for a trusted third party. And that brings us to the second reason why blockchains matter. The same as with data, we can have logic or computations on a blockchain. We do this through smart contracts, which are small pieces of code and which, despite of the name, are neither smart nor are they in the legal sense contracts. For example, an escrow functionality. Only if a certain condition is met, a payment will take place. As these smart contracts live on a blockchain, they are immutable and tamper-proof, so you can be certain they will perform as intended by the developer who wrote the code. Also, anyone can verify that a smart contract was executed as intended, so it makes the integrity of the logic guaranteed. That brings us to the last point, but not the least element, which is, I would say, core to blockchains. They are trustless. You do not need to know or trust your counterparty to be able to transact. You do not need a third party for that, and that makes it both efficient and scalable. Governance is also an integral part of the network, so a user or participating entity, participating entity, you're able to participate in decisions regarding the network. And an example where the trustlessness of a blockchain works very well is in international remittances. If you do that through a bank or another financial service provider, it will be very costly and time-consuming. But you can send Bitcoin all over the world with the press of a button, and it's instant. And you don't need a third party for that, so it saves a lot of time and it saves a lot of money. And that concludes our introduction to blockchain. If you would like to know more, do reach out to us either through our website, warrenbrandis.io, or send me an email at arno.laven@warrenbrandis.io. Thank you very much for watching, and see you next time.